Hello there, and welcome to Chapter 2.4 from the Statistics Think and Do book. This is Measures of Relative Standing. I'm going to switch this over into full screen mode. There we go. Okay, the first place we're going to start here is with quartiles. It basically goes like this. If you recall, the median separates the data into two parts. There's the top half and the bottom half, and the median is right in the middle. Well, you can go one more step further and divide those two parts in half. And what that results in is the first quartile, denoted Q1. It separates the bottom 25 from the top 75. The second quartile, Q2, is the same as the median. Right? And Q3 separates the bottom 75% from the top 25. Right? So you're basically separating the data into fourths, or quartiles. Percentiles do a similar thing, only with greater refinement. And basically what that's saying is that we call P sub k, that's the kth percentile. For example, P sub 50 is the 50th percentile. It now has another name, Q2, or the median. And P sub 90 is the 90th percentile. It separates the bottom 90 from the top 10. So P sub 90 is good, or it's well above the median. Right? Some people switch the 90 and the 10, which is higher, P90 or P10. So the 90 tells you what percent is below that particular score. And so a lot of stats books have many more pages dedicated to these two topics than I do, and that's because there's not complete agreement how to calculate Q1 and Q3. Q2, everyone agrees, it's just the median. And you'd want P sub 25 to equal Q1 and P sub 75 equal Q3, and that's not always the case. So we're just going to start off with percentiles and go back and calculate quartiles. And while this is maybe not the most complete story, it gets us through the information a little quicker. So here's the process for calculating a given percentile P sub k. Right? The first thing you do, and I'll do this generally for you with problems in this book, is you order the scores from the least to the greatest. And then, to find the index of the P sub kth term, you find I by this little formula here. That's I for index. It's k over 100 times however many terms you have. But now there's a choice you have to make once you get once you get I. If I is a whole number, you average the ith value and the next value to get P sub k. Now that's the biggest mistake I see in this chapter, is that you get a whole number for I, and you're like, oh, that's good. I know what that is. It's the ith term. I'm going to call that P sub k. But in fact, if you get a whole number, you have to average that term and the next. If it is not a whole number, you round up to the next value of I to get the index of P sub k. Okay, so here's an example. I have 16 scores from a quiz, I guess. Yes, quiz scores. 16 quiz scores. I wanted to calculate P sub 20. Well, the index is going to be 20 over 100. That's basically 20% times 16. So I'm looking for 20% of the scores, right? There's 16 of them. And so that gives me 3.2. Since that is not a whole number, we round up. And 3.2 rounds up to I equals 4. And so when I say that's the index, I'm saying that it's this value, and the actual P sub 20th score is 31. Right? If I want to calculate P sub 25, similar process, I calculate I first, which is 25% of 16, which is 4. Now your first guess would be to take the fourth term, but actually that's not the case. We're going to take the average of the fourth and fifth. Right? So what that means is we take the fourth term, the fifth term, and we average 31 and 36. All right. So if you take 31 plus 36 and divide by 2, you get 33.5. And that's P sub 35. P sub 25, sorry. For the your turn problem, calculate P sub 75. Here you take 75% of 16, and you get the index is 12, but that means you have to average the 12th and 13th. So we have to average these two. We have to average 43 and 44, which is just 43.5. To calculate P sub 90, you have to take 90 over 100 times 16. That's taking basically 90% of 16, and you get 14.4. Since that's not a whole number, this is actually easier if it's not a whole number. You round up, and you get an index of 15, and that value is right here. And remember, the P sub 90th value is not 15, that's the index. The actual value is 48. Right? Easy peasy. Alright, so the procedure for calculating quartiles. So this is where things get different procedures, produce different results, and not all textbooks agree, and actually not all software does it the same. So to save ourselves the messy business of choosing a method, we're just going to say, well, if you have P sub 25, now that we know how to do that, we're just going to make that Q1. Right. The median is Q2. And that's actually agreed upon in all, by all. And now that we can get the 75th percentile, we'll just make that Q3. Right. And as long as there's a lot of numbers, this change won't make much of a difference. And so once we get the quartiles, and really for us that's just changing the definition of P sub 25 and P sub 75. Once we can do those, we come to a 5-number summary, and then graph that in terms of a box plot. So for example, if I take the scores from this set right here from our previous example, if I look for the 5-number summary, I'm going to use these numbers as an example. So the 5-number summary looks like this. You take the minimum score and the maximum. Those are the two easiest. So when you go back to that data, the minimum score is just here, right? And the maximum score is here. So the lowest I have is a 15, and the highest I have is a 50. Alright, so I'm going to clean this up. So those are my first two, min and max. Right. Min, max. And then I'll go back down. The next 3 numbers are just the quartiles. And we figured these out. We actually got Q1 earlier, because that's P sub 25. P sub 25 we said was 33.5. That's P sub 25. Good. And then we got P sub 75 in this problem right here of 43.5. That's the 75th percentile, also known as Q3. So we have this one. So the only one we haven't already calculated is the median. And that's pretty easy to do because they're already ordered and indexed, right? So there's 16 of these. That means we have 8 down there, 8 up here. So it's an even number. So we don't actually have a middle value, right? So we take the average of 38 and 40, and the median is equal to 39. Right. I'm going to put that in for Q2. And there they are. So that's the 5-number summary. The minimum, Q1, Q2, Q3, and the max. And a box plot basically denotes these 5 numbers. And basically what that means is this is the min. Right. This value is the max. And when I say this min, it's actually this thing down here. It looks like about 15. and the max. So the max is down here. So that's the numbers I'm getting for them. And then this is Q1. What I mean by that is it's right down here at about 33.5. I know because I have the numbers there. This is Q3. Down to there. And then the median, or Q2, is this value. Right? So, but you don't see these vertical lines. You just sort of get an idea of how the data is spread out. If you want to find the actual values, then you have to trace down to here. All right, so for the your turn, we just basically have a different set of scores with 18 here. Let's see, when I look for the minimum and the max. So basically I'm saying look at these scores. Right? There are 18 of them. Find the 5-number summary and create a box plot. So the box plot has been done for you with software. So let's find these values for the 5-number summary. All right, so the easiest two, let's do that first. The min and the max. So that gets us 20 and 50. Now let's do the median. There's 18 scores, so again we have an even number. So that means we have the first 9 and then the second 9. So our median, there is no number right in the middle, so our median is the average of 33 and 38. And so when you take 33 and 38 and average them, you get 35.5. That's the median. Right. So the trickier ones are Q1 and Q3. So for Q1, we're going to say, all right, that has to equal p sub 25. So to get the index, we take 25 over 100 times, what do we have, 18 scores. So that gives us, let's see, doing this real time, 4.5, which equals 4.5. Because that's not a whole number, we use the 5th score. And that 5th score is right here, 29. For Q3, that's p sub 75. So I equals 75 over 100 times 18. And when you do that, you get 13.5. So again, that's not a whole number, so we just round up and we use the 14th score. And the 14th score, right here, 46. So there's our 5-number summary. And to plot these, you need an x-axis down here, and then just some space above it. So, and I usually start by plotting the min and the max. So I go 20, I go up there as the min, 50, I go up there as the max. And I try to find the median, 35.5, so it's just barely more than halfway across here. Gives us this box, or that vertical line. Then I put in my 2 quartiles, Q1, Q3, and then you connect Q1 to Q3 with a box. Right. Pretty easy. 5-number summary, box plot. So I'll just discuss a few details that aren't terribly important, but a little bit. Sometimes your box plots are presented vertically. You know, you'll have a box here, maybe, and then like this. And what you'll then have are x values here. X values. All right, vertical box plot. It'll work the same way. The interquartile range is Q3 minus Q1. It's this distance, right? That distance is called the interquartile range, or IQR. And some textbooks are bold enough to quote the definition of an outlier. And they'll say, all right, if you go to Q1, say down here, and you go more than 1.5 interquartile ranges, that makes you the outlier. If you're more than that away from the Q1. Or if you're more than 1.5 interquartile ranges above Q3, you're also an outlier. All right. And once you have the definition of outliers, you can actually use what's known as a modified box and whisker plot, which displays outliers. In other words, if it gets further than that, if it gets further than 1.5 interquartile ranges above Q3 or below Q1, you're officially an outlier, and what you get is a little star instead of the dot. Right, so you might get a star here and a star here. Right. The discrepancy between Q1 and Q3, I'll give you the short story. Getting Q2 is easy. It's the median, right? And then some texts would say, once you get that median, you throw it out and use the bottom half and the second half and the top half of the data and find the median of that, and that would be Q1. Then you look at the top half of the data and divide that into two parts, finding the median. That gives you Q3. So some texts would say you take that median and you throw it out. Other textbooks would say you keep the median and split it up in some fashion or another. And there's no complete agreement upon that, so that's why I took the shortcut and said, all right, let's just go with Q1 equals P sub 25 because we know how to do that. And Q sub 2 equals P sub 75. As long as you have a large set of distinct values, those things shouldn't be too far off, no matter whose method you use. To get the percentile of a score, suppose you have the score X, your quiz score, and you want to get the percentile. You take the number of values less than X, divided by the total number of values, multiplied by 100. For example, suppose you had on that your turn problem, suppose you had a quiz score of 36. We'll go back up here. 36. How many scores are below 36? Well, it looks like you have half of them. All right. So that's 9. So you have 9 scores below 36. So 9 out of 18. So the percentile is 9 out of 18 times 100, which equals 0.5, or the 50th percentile. So if you got a 36, the percentile of 36 would be 50%. And if you notice, the 50th percentile that we came up with, Q2, is 35.5. So they're close, but not the same. And that's the problem. Sometimes you calculate the percentile of a given score, and it doesn't match that percentile for the data. And there's no easy way to resolve this issue. It can happen. An interesting example of side-by-side box plots, these are vertical box plots, is whenever you look at the example of the draft order for Vietnam. Back when the U.S. was getting the Vietnam War, they were drafting civilians to be in the military. And if you're in this right age group, you were to go sooner or later. And how they determined who went sooner, who went later, was to put all the possible birthdays into a bin, a literal bin. They put on little pieces of paper, spun it around, and just started picking birthdays. And so if your birthday was the first one picked, you got over to training camp and you were in the jungle before you knew it. But if your birthday was late enough, you might have never even gone, right? And so when you look at actually birthdays, and here they just numbered the birthdays 1 to 365, and the draft order in which they were picked, you can't really notice any relationship. That's a scatter plot, and it's dense enough that we can't spot a relationship. But if you take each month and just take the months of the birth dates and separate them out, and then do box plots for the draft orders, right, for each month, what you'll notice, and it's not terribly obvious, is that as the birthdays increase, these box plots sort of shrink back down, right? I mean, the top Q3 here and Q3, these are below a lot of the medians for the earlier birth months. So was that a product of random variation, or was it some problem in the selection process, and people have argued about it for a while, and it's never really been quite resolved. Finally, technology. Box plots can be created with technology, and getting quartiles and percentiles can be done with the various software, with the various statistical packages. And a description of how to do that is found at the textbook website, stevens.com, or stevensstats.com. That's me. All right, that wraps up this chapter, and I'll see you for one more section from Chapter 2.